Hi, my name is Hilal Kargupta, and I'm from Agni. I spent a good deal of time, 15 plus years in the academia. And after that, I co-founded Agni. And my core research interest is in the area of distributed machine learning. Today, we're going to talk about distributed machine learning and its relationship, with the recently coined field federated learning. We are going to talk about the history a little bit, so that's one of the main purpose of this video, to talk about the history, what the field is, and to provide some pointers, in the literature, to the folks who are new to this field and need that introduction. And that's about it. Okay, so this is an introductory stuff, and we'll be publishing more videos and digging deeper into the field of distributed machine learning. And this is just to get everybody started. All right, so let's get started. So this slide talks about what is distributed machine learning and what is federated machine learning, their relationships, that sort of stuff. So distributed machine learning is essentially the field of data science, where you're dealing with environments, with distributed data, distributed computation, and distributed human factors, resources. So that's the general idea behind it. How do you do machine learning, statistics, from distributed data, compute, and human factors. On the other hand, federated machine learning is a relatively new term, and the literature on federated learning seems to be primarily focusing on kind of a restricted form of distributed machine learning. They primarily focus on synchronous algorithm, where all the nodes kind of generate local models instead of sharing the raw data. They share local models, with the global node, and combine the models, and then gradually iterate through that for generating better models. So that seems to be the general focus. And so this slide essentially kind of summarizes that. It has a picture over here, a cartoon diagram that shows different nodes and their connectivity, and within arbitrary topology. So the general idea is that you have data nodes, compute nodes. How do you learn functions or relations, from this environment? Okay. All right. So this slide talks about different ways to kind of look at the DML literature. And there are many different ways, and this slide essentially lists some of the common ones. Data parallelism, for example, like, you slice up the data at different nodes, and process them separately. That's one way. Compute parallelism, for example, those algorithms, parallelize the compute primitives and, get the result, combine the results, and that's compute parallelism. Then you have the clock. All the nodes, if they have the same clock and they're running in sync to update the models, to learn, to compute the task in sync, then those are synchronous algorithms. And if you have clocks that are not necessarily at sync with each other, and the different nodes are proceeding on their own, and they're updating things at their own will, then those are asynchronous algorithms. And then also you can look at the literature from the topology side. Okay, what kind of distributed topology that you're talking about here? You could have, for example, a client-server topology, where you have a bunch of clients talking to a server. You may have like P2P, peer-to-peer kind of topology, less restrictive, less central control, that sort of stuff. And then there are other ways, for example, privacy protection side of the story. So many distributed machine learning algorithms deal with privacy protections. And that's one of the benefits of it, but you have to be very careful about it. Just because you are not sharing the raw data, and you're sharing just the locally generated models or some perturbed form of the data, doesn't necessarily mean that you're protecting privacy. You have to define the privacy model more rigorously. So, for example, secure multi-party computation (SMC) is one framework for defining privacy, and then you have things like differential privacy, and there are other models of privacy. So you have to kind of pay attention to those models and stick to it and design algorithms that protect the privacy in that framework. So those are some of the different ways of classifying the DML literature, and there are other ways. Okay, so I'm going to next, talk about some of the early work in this field, just to get you started. Back in 1995, Sal Stolfo at Columbia University and his students, for example, Philip Chan, did a lot of work in this field. They developed this meta-learning framework where each node would have a partition data, like a slice of the data, to generate local models and then share those local models and then combine them at a global node using the so-called meta learner. And they did different applications on network threat detection, things like that, using that approach. And at the same time, my group at Los Alamos National Lab worked on distributed machine learning, and we kind of looked at applications in the area of distributed text classification, for example. And we kind of did the work in 1995, 1996, around that time. That's when we started. And then we had a tech report in 1996 and published a paper in the KDD conference in 1997. So those are some of the very early work in the field. And the next slide over here, it kind of gives you a timeline of and some of the milestones. And we already talked about some of the early work by Sal Stolfo, Philip Chan, and the team at Columbia. My team's work at Los Alamos, and then at University of Maryland, Baltimore County. Around 2000, we published an edited volume, and it was published by AAA Press, and after that, MIT Press published several edited volumes, on this topic, on distributed data mining. And it's also very important to mention, the team in Technion, Asaf Suster and his students and his postdocs, they did a lot of interesting work, and they continue to do that. And on asynchronous algorithms, local algorithms, for example, for doing data analysis, machine learning, data mining. And at the same time, in between 2000 and 2008, my lab at University of Maryland, Baltimore County, people like Kanishka Vardari, Chris Gianella, Van Wolf, and a whole bunch of others, Kamalika, and Haimanti, a whole bunch of others, worked on Kunlu, Shopik, all of these, folks, like, I'm just mentioning a small subset of those, like, they worked on distributed data mining algorithms, distributed machine learning algorithms, for varieties of topologies, local algorithms, asynchronous algorithms. So all this literature exists, and in 2016, Google published this paper on federated learning. They also made it popular, and there seems to be a growing body of literature on federated learning these days, so the work continues. And the next slide essentially talks about some of the current trends and the challenges, So as I said, earlier, there exists a large body of literature on synchronous and asynchronous distributed machine learning algorithms and applications. And the federated learning algorithms primarily seem to focus on a restricted form of DML that deals with, synchronized data. Synchronized algorithms, I'm sorry. The synchronized algorithms, are useful, but they have their own challenges. They don't scale very well. They're not very fault tolerant. So Asynchronous algorithms, on the other hand, they're difficult to design, but they have their own benefit. They scale up better. Okay, so so there are many challenges on these things. Privacy preserving side, like there are interesting, analytically well-defined models of privacy, but we need to work there. The field of reinforcement learning, using distributed algorithms, that needs more work. So we also had a whole bunch of different early applications in the last 25 years, including commercial products. For example, here at Agnic, we launched our connected vehicle product platform based on distributed machine learning algorithms in early 2000, 2004. Around that time, we had the first introduction of the product, and it's a popular platform both on the consumer and the B2B side these days. But we need new generation of applications. We had applications in IoT and commercial products in that field, but we need applications and products in the area of generative AI, LLMs, and many other fields. So the next slide essentially concludes this presentation and drives the main ideas home. And it first points out that there's a body of literature. The early work existed, started probably in the late 1990s, and then around 2004, the prototypes, early applications, hit the market, and commercial products started showing up around the same time. And Google's in 2016 work on federated learning, brought in new applications, new algorithms. So it's an exciting time to be a part of the field of distributed machine learning. We have a slide over here that sort of provides a handful of early work. This is by no means representative of the literature. In fact, we actually offer a list of related, bibliography in this field, and feel free to look into that. There's a large body of literature. This is only a small subset of other papers, primarily focusing on the early work. And finally, with this slide, we'll be publishing more videos in this field, digging deeper into distributed machine learning. So please stay tuned, and if you have any question, please let us know. Thank you.